we're going to cover today is a total introduction to using SQL for data analysis. So what is SQL? How do we use it to answer some questions we have about a data set? How do we construct basic queries out of SQL? And we'll start to get towards the end of our workshop today towards some slightly more intermediate advanced queries with data that we'll continue on with in part 2 of this workshop next week. Okay, so that's that. Last thing before we set up, who am I and why am I here teaching you SQL? My name is Rachel. I've been working with data for the last 10, 11 years or so in my career in a bunch of industries, nonprofit, consulting. I'm now at a tech startup, and I write SQL every day of my day job. So I promise this is a useful skill. Lots and lots of different types of roles and industries and jobs use SQL, and as obviously various AI tools become more popular, there's lots and lots of ways that you can get to writing SQL, tools that can help you with SQL, and just knowing a little bit about how it works and how to understand it will help you a lot with those tools as well. Okay, I think that's all our intro stuff. Let's get into it. So if you haven't already, make sure you go to this link. That'll bring you to this page. The thing you want on this page is this long link with a bunch of letters at the end, app.hex.tech. That is the one that's going to take you to the tool that we're going to be using for the workshop today, which is a free tool called Hex. They've given us free access to their sort of professional level plan for this class, so we appreciate them for that. This is also a tool that I use every day in my day job. I really love it. I think it's really great, especially if you're a little bit more of a beginner learning SQL, or if you have interest in learning Python. Hex works in Python as well. And you don't have to install anything into your computer. It's all on the web, which is super easy and saves you a lot of setup. All right. So if you click on this link, you'll get a login prompt. Please log in with your USC email or your USC Google or Microsoft logins. Once you're in there, you will see some sort of homepage that looks like this. All right, you probably won't see as many of these, but what you're looking for is spring 2026, week 1. My screen's a little more crowded, so I'm gonna go here. You should see something like spring 2026 SQL part 1. All right, that's the one you're looking for. Once you find that, don't click on it, hit the ... and hit duplicate. All right, you're gonna make your own copy of this workspace. It'll be your own private kind of workbook for today. So you can type as much stuff as you want in there. No one else will see it. All right, so again, you're looking for spring 2026 SQL part 1 once you're in Hex. Once you find that, you're gonna hit the ... next to it and hit duplicate. If you clicked on it already and before you made a copy, that's okay. You can come to the top here, do the drop down arrow and hit duplicate from the top. All right, so if you land on this page, that's also fine. Just go to the top and do the down arrow or duplicate. I'm gonna give everybody a moment to do that because we gotta get everybody onto this step before we proceed. So if you can maybe give me just a little wave or thumbs up when you have your own copy, that would be great. And if you have any issues getting the link to work, excellent. Give me a little wave and I will come help you. For folks that are just getting here, please head to this link and that will get you started. All right, we're good, making their own copy. Issues, okay, having trouble locating it. You can go to projects on the left-hand side. I've got a whole bunch of stuff in here, but you'll probably just see a few things right here to spring 2026. And then just a reminder to make your own copy. All right, so I'm gonna go ... duplicate at the top, and I'm just gonna give my own copy a name. I'm gonna call it something like Rachel's copy. So I know that this one is mine. All right, does anyone not have something like this? Feeling okay? Okay, great. Excellent. For folks who came in, just head to that link on the whiteboard and then make sure you click this big old long link here. That'll get you logged into our Hex workspace and you can follow along with us from there. All right. So let's talk a little bit about what is SQL. All right. I have loaded a little bit of information into our Hex workspace for today. So you can think of this as like a worksheet or a workbook. There's a bunch of blanks. You can make a bunch of blanks and kind of fill those in as we go. Okay. So a couple things that are going on in here. One, You can insert chunks of text in here into hex using Markdown, which is just a text tool. Anytime you see Markdown right here, that's just some text I've put in. This is just a silly little GIF because the data set that we're going to be using for today's workshop is some data about the TV show Seinfeld, which was probably made before most of you were born, but it's the data set that we'll be using today. All right. I've got a little chunk here that I'm not going to explain today. This is a tiny little chunk of Python that's just loading some of our data sets into our data workspace. I teach a separate Python workshop. If you're interested in learning more about that, come talk to me after. So we're just going to ignore this little chunk. All that's doing is loading up our data so that it's ready for us to use. All right. And then I've got a little explainer here for you about what a general SQL query looks like. All right. So what is SQL or SQL? You can call it either one. I will usually be saying SQL. SQL stands for Structured Query Language, and it's a very simple programming language, simple as far as sort of the syntax or the different kind of tools and terms that you can do with it, but quite powerful in the sort of number of things that you can use those tools to do. Okay. So SQL, when written, looks a little different than other code. If you have any experience either writing or reading other chunks of code, for example, the HTML for a website, it tends to look very complicated, look very overwhelming, have a lot of symbols. SQL in general tends to be a lot simpler, at least to start. So if you're kind of new to like dipping your toe into coding, data analysis stuff, this should feel a little bit more approachable to you than some of the other programming languages, which is a reason that I love to teach it. All right. So anytime you're looking at a chunk of SQL code, it's always going to start, your query is always going to start with this keyword select. All right. And there's a couple of other keywords that may be in your query, depending on what's going on. All right. You're going to see this word select at the very beginning of any query that you write. You're also going to see this word from, which is going to say, where am I grabbing my data from? Okay. There are several other things you can do. You can join your data together. You can group it. You can put it in an order. We'll talk about all of these options. So you may see some or all of these in other queries that you write. But just about every query will have a select and a from. Okay. So let's talk about what you are selecting, meaning what data are we working with? Where is that data stored? All right. When you are using SQL, you are accessing structured data. So structured data meaning if you've ever seen an Excel spreadsheet, that is basically how you can picture the databases that we're using. All right. Now, specifically in Hex, you can go up here to your data browser, and it's going to tell you what data we have available for our project. Now, I mentioned up here this little chunk of code that is going to load our data to make it available for us to use. We need to run that code in order for it to show up here. All right. So what you should do is once you have your copy, make sure you're working in your copy of your project. There should be a pink button on the upper right called Run All. All right. You're looking at sort of like the play button. You're going to look for that and hit Run All. All right. It's going to take a second. It's just going to run all of our existing code. Once you do that, you're going to go to the data browser on the left-hand side. It's this thing with a little lightning bolt right here. You'll see an option called data frames. All right. If you don't see data frames right here, it's because you did not hit Run All on this side. Okay. Hit Run All, go to data browser and hit data frames. And data frames will show you what data we have available to access in our project. Okay. We have two data frames to start. We have one called ratings data and one called transcripts data. You can see a little preview here of how many rows are in this data set, right? So we have a relatively small data set with a couple hundred rows and a relatively large data set with over 50,000 rows. When you click on either of these data sets, you can see down here the columns that are in that data set. So what pieces of information are stored in there. You could think of these as columns in your spreadsheet. And same thing with our other data set, you can see what our column names are. All right, anyone have any trouble finding our data frames on the left-hand side? Feeling okay so far? Okay, so that's been a bunch of information to start. We're gonna now start with our very first, very simple SQL query, okay? A very common thing you're going to do as any sort of data analyst, if you're working on any sort of data project, even if you're about to use AI to do a bunch of data stuff, a really good first step is always to look at some rows of the data with your eyeballs. Make sure you get an intuitive understanding of what is actually stored in this data set. What do these values look like? A very common way to do that is just look at the first, say, 10 rows of your data set. So we're going to start with a very simple query that's going to allow you to do that. Okay, I've got a little placeholder box for you right here. It says write your SQL below. This has 2 dashes before it, this little line of text, which means it's a comment. All right, so this is just a little note to myself, note to you. So you're going to want to write your SQL on the next line down here. All right, now go ahead and find this box and type along with me. We are going to start with select. That is how every SQL query is going to start. Conventionally, those terms are written in all caps. They don't have to be in all caps, but they will turn blue in hex, just so you know it's the correct keyword. All right, and we are going to do select star, all right, select asterisk. This is our shorthand for everything. Select all the available columns. Instead of listing all those columns out, I'm just going to do star. All right, so I'm doing select space star space from. All right, see from also turns blue because it's another keyword. Where am I going to select it from? I'm going to select from one of my data frame names up here, okay? So I want to look at both of these data sets. I'm going to look at my ratings data first. So I'm going to start typing ratings underscore data, right? Exactly like how it's spelled here. And probably when you start typing, it'll give you this handy little typing assist to finish that out. So you can just hit tab. And then this is a complete SQL query as it is alone, but we're going to add one more thing, which is just a limit to just give us our first 10 rows, all right? So this query will work for large data sets. It will take a long time to run because it's grabbing everything. So we're just gonna add a limit. It's just the word limit, and then we're gonna give that limit a number. You can give it whatever number you like. I'm gonna give it 10. That means it'll give us our first 10 rows of this data set. The star means it'll give us all those columns, okay? So I've typed all this in. Once you've typed all this in, you need to run it. You can hit the little play icon on the right-hand side of that cell there. You can also hit Command Enter on your keyboard. It does the same thing. All right, so we'll run that. You should pretty quickly just below get the results of your query. So the query is a question that you're asking the database, and then the results are the answer, right? What got returned. Okay. You can also toggle your little data browser closed at the top if it's making your screen too squished. Okay, did anyone not get something like this? Did anyone not get their query to run? Okay, excellent. So next thing we're going to do is just take a look at this data, try to understand what it is. All right, season 1, title. These look like episode titles, pretty straightforward. Air date, these are dates, makes sense. This is when these episodes aired. Rating, all right, this is some kind of television rating scale, makes sense because this is our ratings data set. We have vote count. I don't know exactly what that is, but based on this context, I'm going to guess that the rating here is averaged out of this many votes for this episode. And then there's a description, which is a bunch of text about whatever is going on or not going on in this episode. I can do a little hover and read the whole piece of text if I want to. Okay. All right, so I like to get some intuition for what this data is. Another good reason to look at this data is it can give you a little bit more information about what these columns are. So for example, I don't know a lot about television ratings offhand, right? But just by glancing at this column, I know that Seinfeld was a relatively well-liked TV show. Its ratings are 7 to 8. I'm going to guess this rating scale is a scale of 1 to 10, or 0 to 10, right? That's just some like intuition I have. I don't know that for sure, but just looking at this data, that's a sense that I get, okay? And that's going to be helpful for me if I'm doing some queries later to figure out the average rating or something. I'm going to be looking for that rating to be 0 to 10. So it's giving me some intuition about whether my later analysis will be correct. That's why I will look. Okay. All right. So we are going to now look at our other data set, which is, if you pop your data browser back open, our transcripts data. Okay. So you are going to open up another cell. You can open up as many cells in your HEX project as you want. You can do that by hovering between any 2 existing cells. You'll get this little plus icon in the middle. You're going to hit plus, and all the cells, just about all the cells we're going to be adding today are going to be SQL. All right, so you hit plus and then SQL, and you get another little box. You can add as many of these anywhere in your project that you want for today. You're going to write another query here. We're going to do the same query we did before, but we're going to look at our transcripts data instead of our ratings data. Okay, so we're going to look at the first 10 rows of our transcripts data set. So if I were you, what I would do is I would copy paste this query that we made, paste it on down here, and swap out this table name for our transcripts. All right, so I'll do that along with you. I'm going to look at my other data table. All right, I have my little browser here. Okay, so same thing. I'm just going to take a quick look at this data set, wrap my head around it before we do some more analysis. So this first column isn't really labeled, but it looks like it's just some sort of row number, so I'll ignore that. We've got character, Jerry, George, someone player. All right, so we're pretty straightforward. Dialogue. All right, it looks like here we've got each individual line of dialogue attributed to this character. All right, then we have an episode number, episode 1. We have an SEID. I'm not really sure what that is. And we have our season number. All right, again, pretty straightforward. This must be season 1, episode 1, all the lines of dialogue. Now, even though I don't know offhand what an SEID is, I'm looking here and it says S1E1. All right, I can sort of infer that this is some sort of code that is for season 1, episode 1, right? If I wanted to check that, I could look further down in my data set and see that that is the case. Okay, so again, this is another reason to just look at the rows of your data set. If you just looked at the column headers here in your data browser, it'd be harder to figure out what exactly an SEID is. All right, and one other thing we're going to do for our data sets, another kind of classic step as you're getting started on a project, is to check how many rows you have in your data set. Now, it was cheating a little bit because Hex already tells you, Hex already does this check because it's such a common thing that people want to know. But if in case you're ever not using a tool like Hex, you should know how to count the rows that you have. I will show you that. So you're going to add another cell down here. We're going to write another very simple query. All right, and we can check our result based on what our data browser says. All right, we are going to do select. Instead of just writing star, we are going to tell our query to count star, meaning count everything in this data set. So before we did select star, now we're doing select count parentheses star close parentheses. Okay, and then the rest of our query is going to be the same from transcripts data, except we're not going to add our limit because if we're trying to count all the rows, we do not want to limit the number of rows. Make sense? Okay, great. Once you have this query, you can run it. Again, it's Command Enter on your keyboard or this little play icon over on the right-hand side. And you should get something like this. All right, so just one row instead of the 10 rows we were getting before. One row with one number in one box that will tell you how many rows are in there. It looks like 54,000 rows. And I could go double check that against my data browser and see that it's the same result. Any questions on any of that? Any errors? Okay, cool. Well, we had a bunch of people hold up ones at the beginning of class, meaning I don't know a lot about SQL, and you've all already written 3 SQL queries. So we're off to a very strong start. All right, less than half an hour in, not too bad. All right, so far we've just kind of used SQL to get a sense of the data that we're working with. Let's get into some more interesting questions, right? These are obviously sort of silly data sets. They're not going to tell us much about current events or the state of the world today, but we can still ask some questions about them, right? Even if they're perhaps just a little bit more for our own curiosity. Okay, so one of the data sets we have is every single line of dialogue in the whole run of a TV show. It's kind of an interesting data set, all right? So one question I have right away about that data set is what characters speak the most often? Right, if I have a data set that has one line, one row for every line of dialogue, I should be able to figure out how many lines of dialogue there are per character across the whole show and see who speaks the most, all right? Now, presumably the lead character will speak the most, but we can sort of verify that or check that with some analysis, all right? So that's what we're gonna work on next. I'm going to add a cell down here. Again, we're adding a SQL cell. All right, so anytime I'm starting my query, you're going to need to think about 2 things. One is what information or what table am I trying to draw my information from? And then what information do I want out of that table? Okay, so to answer this question, which table do we need to draw information from? Transcripts data, excellent. All right. So I'm going to I often write my queries like this, sort of in pieces. All right. Your query does not have to be all on one line. It can be separated out into multiple lines. It works either way. Sometimes I separate it out as I'm writing it just for my own organization. So this is what I've got so far. Select something, I need to think more about what, from transcripts data. All right, that's my first thing. So once I've decided what table I'm going to select data from, then I need to decide which columns, which pieces of information from my table do I need to answer this question. Anyone have any thoughts on a column that we might need to answer this question? Dialogue, yep, lines of dialogue, and anything else? And character, fantastic. All right, so I'm imagining that my answer to this question will look something like character name and then a number, right? Their number of lines, character name, and then a number of that character's line, right? So because I want character to appear first, I'm going to select character first from here. All right, you can see since I've already put in my from this table, it's actually going to start auto suggesting to me character, which is great. I'm going to hit tab. It may put quotes around character. That's only because it has a capital letter. You can also take character all lowercase. That will work as well. All right, let me move this up on the screen so it's a little easier to see. Okay, so I'm going to select character from transcripts data, and then I'm going to need my lines of dialogue, but I specifically want to count my lines of dialogue, right? I want to know how many. The good news is we already know how to count stuff from our previous query. That query was counting everything. But in this case, we just want to count our lines of dialogue or our rows in the table, which as a fun shortcut also will work with our count star. All right. So what I'm doing here is I'm doing select character, comma. Anytime I'm specifying multiple things that I want to select, I'm going to separate them with a comma. Okay. And then I need to count something. Now here I could either count the values in this dialogue column, or I could just count how many rows have this character associated. Now, with this data set, I think it's safe to assume that the rows of dialogue are not blank, right? There wouldn't be a character listed with a blank line. So that's not the point of this data set. So in this case, those two things are interchangeable. Okay, either one would work for what we want to do. All right, so I have select character, count of rows from my transcripts data set, sounding pretty good to answer my question. Yeah. So I'm going to run this and I'm going to get an error. Okay. If and when you get an error writing SQL, which you definitely will at some point, including if you use AI tools, the AI has returned many a SQL error for me. If you ever get a SQL error, you're going to look down towards the bottom. Some of them can be quite long. You generally want to look down towards the bottom. Okay. So this error is going to tell me that the column character must appear in the group by clause or be part of an aggregate function. Okay. So we have not talked about group by yet. I'm going to scroll back up to my little SQL guide up here. All right, group by is one of these things that we can add to queries. All right, we haven't used it yet. Okay, so we're going to go ahead and add that. When you add a group by, you need to tell SQL which columns you want to group by. You could imagine if you have a bunch of columns, which ones are you trying to group by and which ones are you trying to summarize, right? So we're going to tell it that we're going to group by character. Okay. I'm going to come back down to my query and I'm going to add another component. Again, you can do this all on the same line or on separate lines. They both work. I'm going to add group by. It's group space by. And you'll notice it'll turn blue for the little keyword thing. I'm going to group by character. All right. So same query I had before that gave me this error. I've just added group by character. All right. And then I'm going to run that. Okay. So I've got some results back. We've got this character audience that has 3 lines in the whole run of Seinfeld. We have this character Artie that has 4 lines in the whole run of Seinfeld. Okay, that's interesting, but still not totally answering my question, which was which characters speak the most often, right? I want to know which people had hundreds of lines, not which people had 3 lines. Right? So that means we need to add another component. I'm going to go back up to my little SQL guide here and look at the other components we can add. One of them is order by. All right, I can tell it to take the results it's giving me and order them by a certain column. All right, so we're going to add that component now to our same query. So I come on back down to my same query that we're working on. Again, I'm going to do this on a new line, but up to you. I'm going to say order by. And in this case, I don't want to order it by character, right? If I order it by character, I'll do it in the demo, it will order by character alphabetically. And it looks like it's going to get some kind of dirty data here, right? Some things that are in quotes and, symbols and stuff like that. That's not helpful. I want to order by the number of lines. All right. Let me take this out and go back to what we were looking at. So I want to order by the number of lines, but what do I call this column? It has sort of this weird count star parentheses name. It's not very nicely labeled. I can give this column a name so I can refer to it more easily later. All right, so I'm going to do that. It's called giving my column an alias. So I'm going to say count star as, and then I'm going to give it some name that I like. Conventionally in SQL, these names don't have spaces in between them. So I might say something like lines of dialogue, something like this. You can just name it lines, anything you like, but right after your count, you're going to do as, which will turn blue, and then some name that you want to call that column. Once you add that name, you can run your query again. Think for a second and you'll see the results are exactly the same, but now we've got a nice little column header right here instead of count star. Okay, so now this is a more logical header. I can refer to this header elsewhere. All right, so next thing I'm going to do is add in my order by. All right, so I've got a select, I've got a from, I've got a group by, and we're adding an order by. Okay, and the thing I want to order by is my lines of dialogue column. Order by lines of dialogue. All right, I'll go ahead and run that. And we're almost there, but now I'm getting all these people with one line of dialogue. All right, I don't want the list to go from small to large. I want the list to go from large to small. So I need to be a descending sort, not an ascending sort. So I'm going to give it the keyword DESC for descending. It's just an abbreviation for descending. I'm just going to add that after my order by, and that's just going to flip it upside down, give us our largest values first. If you've ever seen Seinfeld, you know that Jerry talks by far the most, then George, then Elaine, then Kramer. This will make sense if you are at all familiar with the show. All right. Any questions about how we got here? Did anyone not get the same as this? Yeah. Oh, no. Okay. You have a question?
When I added lines of dialogue as an statement, it gave me an execution error, but then when I added that to the order by line, it worked somehow.
Oh, interesting. Okay, so you were running it just like this, and you got an error?
No, so first we added lines of dialogue on top, right, to label the column. So it was giving me an error up there, but then after that we added that to the order by plus, and then it worked.
Strange. I'm guessing you might have had like an extra comma or something in there, maybe at some point. Because yeah, if it works as the whole.
Okay.
I think, yeah, you should try actually like deleting this line and seeing if it runs. That works. Any other errors or any questions about what we've done so far with this query? Not okay so far? All right. Is SQL more or less intimidating than thought it would be? More? Less? All right, cool. All right, excellent. Okay, did that work without your order? Okay, sweet. Okay, so we have answered a very simple question with our query, which is cool. We could also add one more component to this query if we wanted to, which is this list is quite long. This is summing up every single character that's ever appeared in the show. We can see from our little preview thing, just a little further down at the bottom, that I can actually page this over 33 times. There's 1,600 unique characters that appear. That's a lot. I might want to shorten this to a certain number of rows. Thankfully, we already know how to do that. We use that one of our first queries. That's limit, right? So I can add limit onto this query if I'd like and say, just give me the 10 people who talk the most, or maybe I'll do the 5 people who talk the most. I can just add that limit, and again, I'll get my same result, but just a little bit shorter. All right, so you're kind of getting a sense that there's all these different pieces that we can use, and you can kind of mix and match, combine whatever you need of these SQL keywords to answer the question then, right? Now, something that I want to point out is the order of these terms. These terms have to go in a certain order if they're included, otherwise it's going to get a little cranky. I can show you what I mean by that. So right now we've got our limit 5 at the end. If I try to put my limit a little earlier, for example, it's going to get cranky. It doesn't know what to do with a group after we've already limited our data. The limit has to go at the end, right? So I'm gonna take my limit back out, pop it back on the end, and it'll run. Now, if you scroll back up to our little kind of quick query guide right here. This is the order that things need to go in if you have them. So again, you don't need to include these in all of your queries, but when you have these pieces, this is the order that they need to go in. So limit is always last, order by is always second to last, etc. if it's in there. Okay. It is good to know, yeah, you are going to run into errors. SQL errors are generally pretty they're worded in a pretty understandable way. They can sound a little bit like robot speak, but they're generally going to tell you some useful information. So if and when you get an error, I would say the most important thing is to not freak out. And the second thing is to actually read the text of what it says. All right, you'd be surprised at how often you're able to just figure out what the problem is based on that. Okay, we're going to keep on rolling to our next question here, which is, which season of Seinfeld has the highest episode rating, highest average episode rating? All right, if you remember when we were looking at our ratings data set, each episode has a rating that's probably from 0 to 10. All right, so we're going to average those for each of the seasons of Seinfeld and see which season has the most highly rated episodes on average. So we know how to do a lot of this so far. We haven't talked yet about averages. So I'll show you that. Average is going to work very similar to our count function. All right, we were previously doing count and then parentheses and giving it a column to count. Average is going to work the same way, ABG for average, and then a column to average. It's obviously got to be a numerical column because it's doing math. All right, so we are going to construct a query the very same way. I'm going to hit plus, I'm going to add SQL, follow along with me here. All right, so I'm going to start with a select and a from and start filling stuff in. So first thing is, what table am I selecting from? Which data frame for this query? Ratings, excellent. All right, from ratings, I'm going to let that auto complete. All right, and what columns am I going to need from my ratings data set to answer the question about seasons of the highest rating? What do we think? Season, did I hear season over there? Excellent. All right, season is good. And hopefully self-explanatory, our rating column, right? That's the chunk of information that we want to be able to average by season. All right, so season and rating. Now, often when I'm writing a query, and especially as you're learning, what you can do is write just sort of a partial query and run it, just see if it runs. So often I will do something like this as I'm working on a query. So I know I need these two columns. I haven't even done the average yet, but I'll just do select these columns from this table. Just make sure that works. Make sure these columns look right? You can run it anytime as you're going. Sometimes that's a helpful check, right? But we want to add one more thing, which is our average. So instead of count, I'm going to do my average function with parentheses around my rating column. All right, that's the column I want to take the average of. Just make that one change, then I'll run this again. All right, we've got an error. Okay, this column season must appear in the group by clause. This is the same error we got before. Anytime I'm grouping, I need to tell it what to group by. So SQL is a very literal language. You need to tell it this sort of thing, okay? So thanks to this handy error, I know I need to add my group by, and the thing I'm grouping by is season. So I'm gonna tell it to group by season. All right, give that a run, see if that gets rid of my error. Excellent. Okay, so I've got a more helpful data table here, and I can see that my table is about 9 rows. It looks like there's 9 seasons. Looking pretty good so far. Next thing we want to do is give our little column here a nicer header, right? Any kind of nicer header is always helpful. Anytime you're doing count or average or any of the other functions, it's always nice to add a little alias to give it a good label. So I'm going to do that here with our as. I'm going to call this average episode rating. You can call it whatever you like, but the convention is no spaces. I usually use underscores like this. Okay. We'll run that. The only thing that's going to change is going to be our little header right here. Otherwise, this is the same. All right. And let's see. Since we're looking for the season with the highest average episode rating, we probably want to sort by our episode rating, right? So we are going to sort or order our data. Same thing with using our order by that we did before. All right. And if you check our little guide up here, you'll remember that our order by does need to come after our group by. All right. So we group and then we order. All right, so coming back on down to my query, I'm going to order by. average rating. All right, I'll give that a run. And same thing, I'll need to, it's going to default sort ascending. I want to sort descending, right? I want to know the highest. I'm going to use my keyword DESC. Again, Hex will give you some handy pop-ups as you're typing. So if you can't exactly remember, but you just start a few letters, it'll give you some handy hints. All right, so we'll go ahead and do that. You can tell it's loading, it's thinking over here. And it looks like season 8 had our most highly rated episodes on average. All right, and same thing, if we wanted to be very literal about this question, which is just which singular season has the highest rating, we could add a limit to just return one row. I could limit this to one row and just say, tell me which season has the highest rating. All right. Anyone not get a result like this? Anyone run into any errors? Okay so far? Okay. Cool. So we've used a bunch of these keywords so far. We have used select and from in every single query that we've written. We've used group by, order by, and limit a few different times in a few different ways. All right, next thing we're going to do is figure out how to filter our data down. All right, so far all these questions that we've answered have used every single row of our data. Next thing we're going to do is filter our data down using where. Where is going to allow us to add logic or conditions, like anytime you're filtering on the web, you're online shopping and you're sorting by price or size or new or whatever, that is the type of thing that we're gonna be able to do with our where clause. Okay, so that's what we're gonna do next. All right, so come on down to task 4 is what we're gonna work on next. We wanna know, now that we know this highest rated season, we wanna know what are the names of all the episodes in that highest rated season. All right, let's say we're going to come up with a watch list. All right, we want to know what the names of all those episodes are. This is going to add in a where clause. So again, I'm going to add another SQL cell, hit my plus sign right here, start with my select and my from. All right, so which data table am I going to be using for this question? Ratings, excellent. All right, great, because I want data about those episodes. Very good. All right, and then which pieces of information do I want from this table? The main crux of my question here is what are the names of all the episodes? So I'm gonna want title, right? Title of the episode. Okay, so select title from ratings data. Again, this is just a partial query here, but I can always run this, make sure it's working, looking good so far, making sure this is the right column, etc. Okay. All right. So next thing we are going to do is add our where. So after our from, we are going to add our where. And this is going to be some sort of logic. So you can do the standard sort of equals, greater than, less than, if it's numerical values, right? All of that sort of comparison logic. If you've ever written a formula in Excel, very similar kinds of ideas to an if. But we're going to be doing this in our where. All right. So the fields that we are going to be filtering on, or the column we want to filter on, is which column? Are we set? I want to filter by. Next question. Season, yes, right. We want to filter by season because we want the names of all the episodes in just one season, right? Our highest rated season. So we're going to apply some logic to our column season, all right? Now, this is a moment where I'm going to scroll back up to our initial kind of data exploration query and just see what is the format, what do these season numbers look like? Looks like they're just single integers, super easy, not formatted in any strange way. So knowing that, I'm going to come on back down to my query and say season is going to equal 8, right? Because we figured out from our previous query that season 8 had those highest rated episodes. Okay. So I'm going to add season equals 8 to my query. I am going to run this, and I'm going to see a bunch of episode names. The other thing you always want to check when you add a where clause is how many rows your result has, right? Does the size of your result frame make sense? So in this case, I have, showing on the screen, in this case, I have 22 rows in my result. You can always see in the lower right-hand side how many rows you have. That makes sense, right? As a length of a TV season, at least in the era of cable and stuff, that was a normal number of episodes. So that makes sense, right? These are the sort of things you want to be kind of checking for as you're writing SQL, or especially if you are using any sort of AI tool to help you write SQL. You're doing these little checks as you go, like, does this number of rows make sense? Does this column make sense, etc. That's going to help you get to a clear result. All right. Anyone not get our list of episode titles? Any questions about what we did here with where? Yeah.
I'm sorry, do you mind scrolling it back up to?
Yes, there you go. So all we did is select title from ratings data where season equals 8. All right, cool. We could also add other data to this if we wanted to, right? Like if we wanted to include the actual rating here, we could just add a comma and add our rating. If we wanted these 2 columns of information, right? Totally up to you. We could sort by the rating if we wanted to. If you don't sort, the rows shall just appear in the row they are in the data set, which they were already sorted. So totally up to you if you want to add any sorting or other stuff like that. That goes for any of our queries. All right. So we're going to kind of keep mixing and mashing some stuff together, and I'm going to show you a little taste of some more advanced, more complicated SQL functions. We'll cover a bunch more of this kind of stuff in the next session, but just want to give you a taste of the sort of types of things that you can do with SQL beyond some of the basic stuff that we've covered so far. All right, so next thing we are going to do is do some sort of combining of our data sets. Okay, so we're going to do a bunch of kind of data cleaning analysis steps that are going to allow us to combine our data sets, right? The reason that we want to combine our data sets is that's where the kind of interesting pieces of analysis come in, right? If we have some information about the ratings of our episodes, sort of an outcome, and then we have some information about what actually happened in those episodes, in this case, a line of dialogue, we can start to draw some sort of cause and effect analysis or conclusions, right? If in episodes where a certain character speaks more, do those episodes tend to be more highly rated, for example? Or we could do some more complicated like sentiment analysis on the dialogue in each episode and see are happy episodes or sad episodes or dramatic episodes getting higher or lower ratings, right? When we start to combine data sets, we can answer much more interesting questions, and that's where SQL gets really, really powerful. And you can do a lot of interesting stuff. The questions we've answered so far are not uninteresting, but they're pretty simple, right? They're pretty kind of cut and dry types of questions. Combining data is going to get a lot more interesting. Okay. So we are going to work on that now. In order to combine our 2 data sets, we're going to need to do a bunch of prep. So before we get into the specifics of that, I'm going to scroll back up and just look at our 2 data sets to sort of understand how we're going to combine them. Let's go back up to our little previews here. All right, so here we have our ratings data, and here we have a couple rows of our dialogue data, okay? Now, presumably, if I'm going to do any sort of analysis, I need to make sort of the unit size on these 2 data sets the same, meaning this data set has some information per episode. So I'm going to need to get my dialogue data set down to some sort of per episode or per season summary, right? I sort of want these to be on the same scale. That makes sense. All right, so I can combine them. I want, for example, average episode rating per season, and then how many lines did Jerry speak in that season, for example, right? Once I have 2 data points sort of at that same scale or granularity, then I can start to do some analysis. All right, so that's one sort of step I'll need to do with SQL before I can do that kind of ask those kinds of questions. The other piece of information that you need when you combine a data set is you need a key. A key is a column or a value that it exists in both data sets that'll match. So you can match 2 rows together from different data sets. You can imagine this happens on databases all the time, right? For example, at USC, there's some central student database. It has everyone's email. And then there's the class registration database, which has which classes you've registered for. And they can then join that together. So they can do things like calculate your GPA, right? They're joining on your email address, your student ID number, some unique value that exists in both places. That's how they're matching that information to you. So we are going to need that information, some sort of piece of information like that between these 2 data sets. Right now, this data set is not about people. When it's about people, you can use an email address, phone number, ID number, whatever. We don't have that. So we need something else that we can add to identify a specific episode. All right. So if we're going to be able to summarize this information by episode, this information is already summarized by episode. How do we match an episode from this table to an episode in this table? Now, if we're just doing this as a human, this is pretty straightforward. All right. Because here we already have this season episode ID number, this SEID thing we saw before, right? SE01 or SO1, E01. Now that we know we can group in SQL, right, I could do some sort of grouping or counting of these lines by this SEID, and that would give me sort of a row for each episode with whatever information. Okay. Now in this data set, our data set is already just one row per episode. But if you look at our columns pretty carefully, our columns in our ratings data set are season title, air date, rating, vote count, and then the dialogue itself. There's not actually any identifier of an episode number in this data set. Nothing in this data set tells us the episode number. Now, we as humans with eyeballs and brains can look at these dates and sort of see for ourselves that, like, yeah, it appears these are in order. So I can assume that this first one is episode 1 and the next one is episode 2. But the data set doesn't actually say that. And because the data set doesn't actually say that, SQL has no way to know which row from here would go with which row from here. That sort of disconnect makes sense. So we have everything we need to be able to connect the two, but we're sort of missing that middle. We don't have that matching column, so we're going to create it. We're essentially going to add a column to this table that's going to calculate what episode number it is. And we're going to, once we have that, we can use that to join our two tables together. Okay, we've got a few steps to do. That's the next kind of chunk of tasks that we're going to be doing. So I want to make sure you have the big picture before we get into the weeds. Any questions about what we're doing or how these two data sets relate to each other? Feeling okay so far? Okay, cool. Let's get into the weeds then. Okay, so first thing we need to do is add an episode number to that data set that's missing episode numbers. So our ratings data set, as you'll recall, has no column for what number of episode it is. So we're going to use some more complex functions to add that number. So we're essentially going to create a column called episode number and fill it in. Okay, so that's what we're going to do in piece number 5 here. I'm going to add a cell, add a SQL cell here, and we're going to use a couple of new functions. All right, so first thing I'm going to do is set up my select and from, like I do for every SQL query that I'm writing. All right, I'm going to fill in my table. Obviously here we're talking about our ratings data set because what I want to do is add a column here from my ratings data set. All right, and what do I want to do here? I don't want to get rid of any information. I actually want to add information. So I want all my information plus some more. We already know how to get all my information. That's select star. We did that at the very beginning. And we also know how to separate pieces of information with it, which is a comma. All right, so I'm going to say select everything, comma, and some more stuff that I am going to generate. All right, so we are going to use a couple of functions at a time. SQL has a built-in function that'll just tell you the row number of the data set that you're in right now. You can think of lots of reasons why that's useful for various sort of math things, right? So we're essentially going to generate a row number and as its own column going on down, right? So it's got this built-in function called row underscore number, open, close parentheses. All right, these parentheses are for functions in SQL because this row number function doesn't need any inputs to it. It's just got these empty parentheses. All right, so we need our all of our columns plus row number from our ratings data. All right. Now, the next thing we need to do is we need to tell it where to add these row numbers. Okay, so what we don't want to do is add row numbers all the way down. We don't just want to know that this is episode 172. We want to know that it's season 4, episode 8, right? We want to know the number within the season. So we're going to use this other function, partition by. Partition by is going to say, execute this row number function until the season number changes, and then start over. Then start doing your row number function again until the season number changes, then start doing your row number function again. All right, so it's basically what we would do, right? If I had printed out our ratings data set and asked you to fill in our episode number, you would write 1, 2, 3, 4, 5 through season 1. When you got to season 2, you would start over again from 1, right? That's what we're going to do here with this function. All right, so we have this piece here. I'll copy paste this on down, and I'm going to give this a name. All right, something like episode number, right? All right, so push this out onto a new line so it's a little easier to read. All right, okay. So once you have this, you can run this. Again, I'm just copy pasting this little chunk I gave you here, row number over partition by this little chunk. then you want to give it a logical column name. Now what we're trying to give it is our episode number. All right. So once I do this, I'm going to notice a couple things. I'm going to notice that I have all my same columns that I had before in my results. But if I scroll to the right a little bit, I also have this new column all the way on the right that says episode number. All right. Now I'm also going to notice something a little funky, which is that it's now going to start with, for me, it's starting with season 3. That's okay. Everything is okay. When it's doing our partition by season, it's sort of treating each season as its own chunk. It's not necessarily keeping those chunks in order. That's okay. Everything is fine. We can still order by our season to get everything back in its proper order. All right. So now we've got our same order as we had before. And we will see now, if we scroll to the right, look at our episode number column. We have 1, 2, 3, 4, 5, and then it starts again at 1. All right. And if I go back over to check on my season number, we have season 1 for 1, 2, 3, 4, 5 rows. And then we have season 2 starting here. All right. So this row here, season 2, is where my episode number, my new column, starts again from 1. Make sense? Season 1, season 2. If I scroll down, I'm going to see the same pattern sort of continuing. So you can check on your pages here if you want to kind of convince yourself that that's working. Like this one's 23. That's where it goes from 4 to 5, etc. All right. Everyone understand what we're sort of doing here. So we've sort of generated an episode number because this data set was missing it. The way we did that is we said just count the number of rows. So 1, 2, 3, 4, etc. within each individual season. So divvy it up by season, count the number of rows, and then do that for each season, 1 through however many episodes there are, however many rows. And then we've saved that sort of calculation or that logic to this column called episode number. All right, so now we essentially have this augmented data set added in. All right. Any questions about what we did here with our adding in our episode number? Did anyone get any errors with that? Okay, fantastic. All right, so next thing that we are going to do is, I combined 5 and 6. We already did this part. We partitioned by row or by episode by season. Oh my goodness, we could partition by season already. So that part is done. Okay, so I'm gonna skip down here to number 7. All right, what we're gonna do here is summarize our transcript data, right? Because we need to get it to that same granularity. We need to make our transcript data into something that is 1 row per episode because our readings data is already 1 row per episode, right? So if we have that 1-to-1, we'll be able to join. So what we are going to do here is summarize our transcript data. So it tells us which season, which episode, and the number of lines. In a moment, we're going to add the number of lines for a specific character using a new function we haven't used yet. But what I would like you to start with is a query for all of our transcript data grouped by season and episode that gives us the number of lines in that episode. Okay, so you should add a SQL cell here. And I'm actually going to let you have all the tools you need to do this part. All right, take a stab at writing your query for this. Your result should be, so you're going to be working with your transcripts data table, and you should have at the end 1 row per episode with season, episode number, and just the total number of lines. I'll show you how to do a specific character in a moment. Okay, so I'm going to give everyone a couple minutes to do that. I'm going to float around. If you're stuck, give me a little wave and I will come help you. All right. Any questions? Hey, does anyone feel like they have a summary of their transcript data by episode? Just a little pulse check. Anyone feel like they're there? Do people need another minute? Thinking about it? 1 more minute. All right. Who's got something with our transcript data? It's okay if it's an error. It's okay. Who's got like something? Anybody? All right. Let's take a stab at it together then. Okay. So we are going to construct this query the same way we've constructed our other ones. All right, we're going to start with a select and a from. What are we going to be selecting from for this question? We're going to be selecting from our transcripts data, right? We're essentially transforming this data set into one that's a bit more squished down, more summarized. Okay, I should be selecting from my transcripts data. Okay, hopefully your query has these components so far. Very good. Okay, next thing we're going to do is figure out the columns that we need. Okay, now I sort of gave you a big hint in our question here. We need season number, we need episode number, and we need the number of lines. Okay, So I'm gonna check here. This is the reason that the data browser is super handy. You can always double check exactly what the names of the columns are in your data frame. In this case, it's season and then episode, no. It's then short for number here. So I'm gonna select those two columns to start, season, comma, and episode number. Again, it's gonna sort of prompt me with an autocomplete. I could also just type it in all lowercase and that would also work. All right, up to you. They will both work. Okay, so I've got my initial columns that I might need. I've got my table that I need. I'm just gonna run that and make sure that I'm generally on the right track. Looking good so far. Okay, and then the next thing I need is number of lines. How do we get a number of something? Count, very good. So I'm gonna do another comma and then do a count. In this case, I'm just gonna count all the lines in that season and episode combo. All right, so I've got season, episode, and I've got a count. Now, as a reminder, when I'm doing my count or average, it's nice to add an alias. So I'm going to say something like number of lines like this. All right, if I were to run that, I would get an error because I forgot my group by. Very good. Okay, so I'm going to add my group by. And in this case, I want to group by two things, right? I am not only counting by season, but I am also counting by episode. So I need to tell it two columns to group by. So I'm going to group by season, and anytime I'm going to tell SQL multiple columns, I'm going to separate them by a comma. All right, that's going to know it's multiple columns. So I'm going to say group by season, comma, episode number. All right, and then I'm going to go ahead and run that. Okay, great. And now I will see I've got a handy little table here. It should have a small number of rows. It looks like it does, right? So this table started at like 55,000 rows. Now that I've summarized it, things in the way. Now that I've summarized it, it's not too much smaller number of rows, right? So it looks like my group is working. Okay. And I can see I've got my columns that I need. I've got season, episode number, and number of lines. This number of lines is like a few hundred. That makes sense. Whereas the number of lines that could fit into a 30-minute drama, right? Especially if people are talking kind of fast. Okay, so this all kind of checks out so far. It's passing the gut check. Last thing we're going to do, it looks like our episode numbers got shuffled a little bit, right? So it's episode 2 and then 3 and then season 2, episode 1. That's not the best. It's not the most intuitive. So I might add a sort or an order by after my group by. And same thing, I can sort by multiple columns. So in this case, probably the most logical sort is to sort by season and then episode, right? All my season 1 and then those episodes in order. I'm going to add an order by. Same deal, season, episode number. Okay. So hopefully you had something that looks like this or something that looks similarly to this. All right. Cool. So this partially answers our question. We've done our sort of group by and order by 2 columns here. All right, which is new. We did that by 1 column previously. And now we're going to add one more component to this, which is that we now know the total number of lines that were spoken in each episode, but we also want to know how many lines were spoken in each episode by the specific character Elaine. Okay. So we kind of need to do some filtering, right? We did some filtering before with our where clause, but in this case, we kind of only want to filter for this one column, right? We're essentially adding a column that says lines by Elaine, right? And that's going to be a number that's, less than or equal to this number, right? But we also want this, we want the sort of context of the total number of lines that she's speaking. So we don't want to use a where clause, because if we use a where clause, all the rows where she's not speaking are going to fully fall out of this data set, and this column is going to be sort of meaningless. So we just want to filter on one column, right? So in order to do that, we're going to use something slightly different than a where clause. We're going to use a case statement, right? Which is going to work very similarly to a where, but it's a little bit more complicated to write. All right, so I'm going to add a comma. I'm going to do this on a new line just so it's a little bit more clear. All right, and we are going to add our case statement. I usually wrap my case statement in parentheses like this, and then I'm going to type the word case. Now, anytime you're doing a case statement, you need to tell it 3 pieces of information. You need to tell it when some condition applies, then what should we be counting, and then you need to tell it to end. You need to tell it that the case statement is over using the word end. SQL is very literal. All right, so case, when, then, end is sort of our little skeleton that we're going to fill in here. All right, so this is again where SQL feels a little bit like some kind of robot English. All right, it's kind of like a sentence, but it's very clunky and row body, okay? So when is going to be the piece of logic that kind of works like our where clause, okay? So if we're going to count the number of lines that Elaine is speaking, which field here is going to tell us that Elaine is speaking? Which column do we want to kind of filter by for this purpose? Character, excellent, because that's the column that's going to say Jerry or Elaine or George or whatever. So what I want to say is in the case when the character equals Elaine. Now, SQL is going to be pretty specific about matching the text. So I'm going to go scroll back up to my data set from before and check if the names are all caps or spelled regularly, anything like that. So I'm going to just scroll back up real quick. This is something I would recommend that you do as well. Okay, if I just glance at my transcript data, even though Elaine isn't listed here, it looks like all the names are in all caps. So I'm going to need in my case statement to put Elaine in all caps, all right? Another reason it's good to eyeball your data because you can learn stuff like that about it. All right, so when character equals Elaine, now when you're giving SQL a chunk of text, you need to put it in single quotes so that it's interpreting it as text rather than another column name. All right, so I'm going to put Elaine in single quotes. Hex is also going to help you out here and turn this sort of an orangey red when it's recognizing it as text. So single quotes when you're doing any kind of comparison to text. All right, so when the character equals Elaine, then I need to do something. All right, now in this case, I want to just count the lines of dialogue that she has. So my count is going to work very similarly to this, meaning count is going to be on the outside of this whole thing, and the thing I'm counting is on the inside. So the thing I'm counting here is just her lines of dialogue, which are just in this dialogue column here. So case when character equals Elaine, then dialogue. Okay, meaning take a look at all of our rows. If that character column equals Elaine, count how many times there's something in that dialogue column, and then end. Okay, that's what we're sort of instructing it to do. Now, the last thing I need to add is I need to make sure I have my count function outside of this. So just right before my parentheses here, I need to have my count function. And again, it's going to count whatever is inside of that. All right, last thing I'm going to do here, because this is a count, again, it's not going to have a nice name for this column when it spits it out. So I'm going to give this a nice descriptive name, something like number lines Elaine. All right, now I don't need to edit my group by or my order by at all because this column that I've added here is also a count. It's not something else that I need to group by. So I don't need to change any of that. I should be just about all set here. So I'm going to try to run this moment. You won't notice this a ton because we're working with relatively small data sets, but anytime you add more complexity to your SQL query, as your queries get more and more complex, they will take longer and longer to run. All right, if you get to the point where you're writing a whole bunch of SQL all the time with big data sets, there's a bunch of techniques you can use for things that'll run faster versus slower. Typically, if you're going to be working with data sets that aren't that large, you don't need to worry too much about that. Modern tools like Hex can run queries pretty quickly, even if they're somewhat large. So you're all good. Okay, so I got my same results here, but I have this new column, number lines Elaine. All right, looks like in this first episode, she's got 53 lines. Looks like she's saying about 10% of the lines. This number is smaller than this number, right? Which makes sense. Everything is checking out so far. Okay, any questions about what we did here with our case statement? Yeah.
Star, what exactly is it counting and how does it know that it has to?
Yes, so it's counting the number of rows. In this case, because dialogue is sort of all filled in for every row, we're all good. If I had told it to count dialogue specifically, it would skip any rows where the dialogue sort of field is blank, which there are certain cases where you might want to do that for certain data sets. In this case, I'm not too worried about it because I would assume if there's no dialogue, there's going to be no row in this data set, but that would be a good assumption to check if this were like a hardcore data analysis project. Yeah, good question. Okay, feeling okay so far. Okay, great. So the next thing that you're going to do is you're going to modify this query that you just wrote. You can either modify it in that same box or you can copy paste it down to a new cell and keep on working. All right, but I want you to add a couple more columns to this result. Okay, so we just added our column for the number of lines that Elaine has in each episode. Yeah. Next thing I want you to do is add 3 more columns for each of these characters, okay, Jerry, Kramer, George. So you should have 3 more columns in your result. Number lines Jerry, number lines George, number lines Kramer. Okay, you're going to use that same sort of case logic with some commas in between, but you're gonna switch for those characters. All right, so up to you if you want to edit up here or copy paste what you have on down. I'm gonna give you all a minute to do that. Your results should have 3 more columns than we had before. All right, who's got a number of lines for Jerry? Anybody? Yeah, up here? I'm gonna make a copy of this guy. Start fresh down here. All right. What do we do to get the number of lines for Jerry?
Oh, we just changed the character name to Jerry and then change the song.
Very good. We will change our character name from Elaine here to Jerry. I'm going to do it in all caps again because it looked like all those character names are all caps. And then I'm going to change my column name right here to also be number of lines for Jerry. All right, we'll go ahead and run that. We're going to get an error. Okay. In this case, it's going to tell you there's a syntax error at or near count. Okay. If you don't know what syntax error means, it's basically like there's probably a typo or a missing word or an extra word somewhere. When it says near count, it's going to be sort of like before or after that. So if you ever get an error like this, you should see what sort of word it's telling you and go sniff around where those are. All right. In this case, the stuff after both of my counts looks pretty good, right? I copy pasted the thing that worked. But you'll notice before this count, the end of my line here for number of lines Elaine, I don't have a comma. Okay, so SQL doesn't know that I'm specifically missing a comma, but it knows that something is wrong somewhere around this word count, so it'll tell me that there's a syntax error. All right, if I add a comma, I should be able to run this just fine. All right, and now I'll see that I've got my number of lines Elaine column like I did before, but I've also got my number of lines Jerry. All right. And same thing, I can just copy paste this on down. This time I'm going to remember to add my comma, and I can swap in any other characters that I like. In fact, anytime you're writing a similar SQL query to one you've written before, I would encourage you to copy paste the one you had before that's working and just change stuff. All right, that's a thing that will help you avoid typos or forgetting parts. All right, so same thing, I copy paste all the time to avoid that sort of thing. I'll add one more for our character Kramer, and then I'll change my variable name over here to Kramer and go ahead and run that. All right. So now I've got a bunch of different columns sort of summarizing this episode, right? Summarizing some information about the dialogue in each episode. Now, you might notice if you go to your data browser, the little lightning icon in the upper left here, you're going to notice that when we started that out at the beginning of this, we just had our 2 data frames, our ratings data and our transcripts data. And now we've got a whole bunch more data frames with lots of stuff going on. If I click on any one of those, I can see what columns they have. This is basically a little index of all the results of the queries that we've run so far, which is really cool because you can now refer back to any of if you look down below any of the cells that we've written, so this one we just wrote for me is data frame 9. For you, it might be a different number if you had more or less cells than I did. Okay, but this is data frame 9, and I can select and query from data frame 9 as much as I want to. So I could come in here, for example, do a new SQL cell and say select star from data frame 9, just like it's one of my other tables, and I'm going to get all my same results. Okay. This is another reason that Hex is super powerful. You can sort of write your queries in different segments and then refer back to them without having to rewrite your whole query. Super powerful. Okay. Now, the other thing is that data frame 9 or whatever number it is for you is not that meaningful to the contents of this. So if this is a data frame you're going to be referring back to, I would encourage you to name it something useful. All right, so I might label this one. You can just double click underneath the cell where you defined that data frame and give it a helpful name. Again, no spaces, you want to use underscores. So you might want to give it a helpful name. I might call this something like episode dialogue summary or something, whatever you like. I'll type that in, I'll hit enter. And I'm going to notice Hex is going to be really helpful and just automatically update it downstream for me here where I had this other query. Super sweet. It's also going to update it over here for me in my data browser. Also super cool. And the last thing is it's going to populate this little number next to this my name here, which tells me how many times am I querying down below from this table, right? Just some handy little stuff it's doing for you alongside. All right. Oh, and then the last thing is if I make any edits then to the results of this query, those edits will filter down below to any other queries that are depending on that one, right? So it's sort of it goes from top to bottom. It's sort of a downstream thing. So let's say we were to make some sort of edit to our episode dialogue summary. That edit would move down here. So to show you what that looks like, let's add one more sort of piece of information to this data set. So we now have the total number of lines as well as the number of lines by some specific main characters. So we might want to add some sort of way to compare across episodes, maybe a percentage, right? What percentage of any given episode is Elaine talking, for example. So we can do that. I'm going to add a comma here and just add some sort of simple math. You can do any sort of math operations that you can do in Excel or anywhere else in SQL. Very similarly, so I'm going to add a comma. I'm going to come down here and just do a percentage. I'm going to do the number of lines Elaine divided by my total number of lines. Just get the percent of the time that she's talking. Right? I'm going to do number. Let's see what I name it. Number of lines Elaine. Then I'm just going to do divided by, just slash number of lines. Spell that correctly. Number of lines. All right, just to get a percentage, and then I'm going to give this a little alias called percent Elaine. Okay, so all I'm doing here is just some really simple math, just a slash. You do addition, subtraction, multiplication, etc. the same way. If you needed to, I'm going to go ahead and run that, and I'll see all the way over on the right-hand side because these columns are always going to appear in the order that I list them. I've now got this column for percent Elaine. Yeah, this is sort of an ugly column. It's formatted as a decimal. It's not showing up as a percent. If I'm going to be displaying this data to anyone else, I can click right here and have hex format it as a percent for me. So I can click my little header and ask it to show any number in any specific format that I want, currency or anything else. In this case, I want it to display as a percent. So I'm going to do hit my little header right here where it says percent Elaine. Hit format, and then I'm going to choose percent here, click out of this, and then I've got sort of a much nicer little display here of that percentage. All right, I could do the same for another character, right, with this same logic. So if I were going to do that, I would just copy paste this and change the numerator of my division here. So I would say maybe I want to know how many lines does Jerry say, and we'll call this percent Jerry. Okay, same thing. Once it runs, it'll appear all the way on the right-hand side like this. And if I want to change that format, I just hit my little header. I go to format in this little pop-up and I can change it to percent. All right, so Jerry talks 44% of the time. It's a lot, possibly too much. Matter of opinion, I suppose. Okay, but now that I've made these changes to my episode dialogue summary data frame, I can see in my data browser on the left-hand side, if I scroll in my columns here, I have my percent Elaine and my percent Jerry. It's just below the bottom of the screen here. And if I go down to this cell, right, which is my cell that I made that just refers back to this data frame we just made, that one will also update over on the right-hand side. It's not going to catch the formatting updates, but it'll catch the content of that data right here. So any adjustments that you make upstream flow downstream without you having to make extra changes, right? I didn't have to go add those columns here as well. I already grabbed them from up above, which is super handy. All right, any questions about our episode dialogue summary piece? Okay, so just to go back to our overarching narrative here, we were trying to join these two data sets together. We couldn't do that originally for two reasons. Our episode data set was missing its actual episode number, which we fixed with our row number formula. And then our transcripts data set had too many rows, right? It had a bunch of rows per episode. We needed to sort of aggregate it up by episode. That's why we did these queries with group by on our transcripts data to group it, aggregate it down to a same size data set as our ratings data. Okay, so now we have two data sets for season and episode, each with one row per episode. Now that is material to join together, which is the last of the sort of SQL keywords that we haven't talked about today up from here, right? We've used select and from every time. We've used where a little bit. We've used group, order, and limit a whole bunch of times. All right, and now we're going to use join, okay? Once you join two data frames together, you can still do all this other stuff. But the join is going to be first after from, because you can't do any of this other stuff unless you know what all your columns are going to be, right? What all is being joined together. All right, so we are going to do that. I'm going to come on back down here to the bottom. Okay, so we're going to join our data. I'm going to add a data frame for this. Same old, I'm going to start with my select and from. All right, in order to join my two data sets, I'm going to need to pick one to start with. All right, I'm going to need the one I'm just going to start with, and then the one I'm going to add on. In this case, it doesn't really matter. We'll talk a little bit more about the nuances of that in part 2 of this workshop. But in this case, my data sets are basically the same size, so I'm going to be good to go to just pick one to start with. Now, which data frame do I want to start with? I'm going to start with our ratings data frame, but specifically the one that we added the episode number to. So that one where we did our row number partition by formula. So I'm going to go back up and find that one because I think it's probably one of these just mysterious data frame number ones. Let me go check that. Yes, that appears to be true. Okay, so for me, it is data frame 7 is this one where I did row number over partition by season. I want to give that a more meaningful name for when I refer to it down below. So I'm going to come to where it says data frame 7 right here and just give it a fresh name. I'm going to call this something like ratings data with ep number. Okay, or just something descriptive so that you know what it is besides, data frame 17. Okay. Once I have that name, I'm going to come on down to my query that I'm working on, and I'm going to say select star from that new data frame I just labeled. Again, it's going to help you out with the autocomplete here. So from ratings data with episode number. All right, I'm going to just run that and make sure that's all spelled correctly. Looking good. I'm going to scroll over and make sure it has episode number. Fantastic. Okay, we're getting very close. The next thing I'm going to do is add my join keyword, which we haven't used yet. All right, so I'm going to use my join, and this is where I'm going to grab that transcript data that we just summarized by, or the transcript data that we summarized by character or by episode. So I'm going to go check what I named that guy, which is up here, episode dialogue summary. All right, so that's what I'm going to say after join. I'm going to give it the name of that data frame. Okay, I'm going to do my little autocomplete. Very good. And then I'm going to need to tell it which columns to join on. Okay. So in this case, we have episode number and season number here. And in our ratings data set, we have an episode number and a season number as well. Or sorry, our dialogue. Here we go. Okay, season and episode number. Now, our column labels are still slightly different. Okay, which is going to be a little annoying for joining them, right? In this table, it's season and episode no. And over here in this one, it is season and episode number. Okay, slightly different, slightly annoying. It'd be more helpful if they were named exactly the same, just to make it a little easier on me to join them. So I'm going to make one modification before we continue with our join. So I'm going to need to give it which columns it should match. Okay, I want those columns to have the exact same name in both of my tables. So because this one is episode underscore number, and in my other one it was episode no, I'm going to go ahead and edit it to be the same as, so it's the same between my two tables. Okay, so I can edit either one. I'm going to go up to just my episode dialogue summary here since it is closer. Okay, and I'm going to give this field, this episode number, an alias, just like we have been doing with our counts and our averages. I'm going to add an as. You can do that to any column that you like, sort of rename it. I'm going to do that, and I'm going to rename it episode underscore number, just so it matches how that column is labeled in my other data set. Those labels match exactly. All right, so I'm going to make that edit here. I'm going to run this cell, and I'll check that my results look the same, but with that episode number and episode number. All right, I can check on my data frame, just make sure those are the same. Okay. And then I'm going to come on down to my join query that I was working on. So far I have select star from one table, join my other table. All right, order doesn't super matter in this case. And I'm going to now need to tell it what to join on. So I'm going to use this keyword using, okay? Using parentheses one or more columns in a list. All right, now in this case, I want to join on 2 columns, season and episode in that order. So I'm going to give it season and episode number, just how I've spelled it here with my underscore. All right, episode number does not exist on the left side of join. All right, let's make sure I didn't go, oh, because I've misspelled EPIO. I did not spell this correctly, right? So I'm going to check my spelling. Episode number. Okay, so you want to make sure you grab your ratings data that we added that new column onto, and you want to make sure you grab our dialogue or transcripts data that we summarized by episode, right? If you tried to do this with our original ratings data and our transcripts data, this would not work. All right, but I'm going to do this with our 2 column names that we've added, and I should get a result that looks like this. I can scroll on over and see for each episode, so we've got the title, the air date, etc. I can now see how many lines Elaine had, Jerry had, percentage of those lines, etc. All right, so now I've got my 2 data sets joined together. This is super cool because now I can do any sort of data analysis that I want to do on this data set. For example, let's say you have a hypothesis that the more one character speaks, the higher the ratings are. Now you have a data set that you can use to answer that question. Okay. We're going to get a little bit more deeper into various more complex queries, more ways you can combine queries, etc. in part 2 of this workshop, which is next week. But the last thing I'll show you from this is just some kind of quick tools you can use within Hex to start exploring this data that we've put together. If you've ever used Tableau or Power BI or any other kind of graphing tool, Hex has a lot of that built in as well. So you can use any results of your SQL to make a quick chart or graph, which I think is really useful. So once you have your data set here with all of our data joined, you can come down to add a new cell at the bottom. Instead of hitting SQL this time, I'm going to hit chart. And that is going to allow me to make a quick chart of any of the data that I've just created. Right, it's going to give me this little blank canvas. I can ask what it wants, or it's going to ask me what I want on the x-axis, the y-axis, and I can make start doing some quick analysis. So let's say I want to see, is it the case that episodes where Elaine speaks more often, the ratings are higher? I think they should be, but I don't know. Let's check the data. All right. So I'm going to put on my x-axis this % Elaine column that we had, % of time that she is talking. And on the y-axis, I'm going to put rating. Okay. Now, this is going to have some of the same little quirks that most data visualization tools have, meaning here it's going to do a sum of our rating. We probably want to do an average here instead of our sum. And then we also probably, just for the purposes of this quick little exploration, I'm going to do this as a scatter plot instead of a bar chart. All right. So on the bottom here is the % of time that Elaine is talking, and on the vertical axis here is the rating of the episode. Looks like really what this is telling us is most episodes were rated like 7 to 8-ish. There's not a ton of variation, but I could try this with any of those columns that we created, right? Any of those specific characters. I could test some hypotheses, start to see visually if there's any correlations in my data. All right, this is super cool because we couldn't do this 2 hours ago at the beginning of this workshop, right? We had some information about the ratings, we had some information about the dialogue, we couldn't put it together, and we certainly couldn't summarize it in any way like this without all these steps that we did in the interim. All right, so we covered kind of a bunch of bases of the basics of SQL queries. Every single SQL query, no matter how advanced you get in writing SQL, is going to look like this, is going to use a bunch of this logic. It's going to use more logic as well. We used count and average functions today. We used some basic math. We used a case statement. We dipped our toe a little bit into some more complex formulas with our row number situation. All right, there's a bunch more stuff like that that you can do in SQL, and you can keep sort of combining that with all of this stuff that we talked about. Combine multiple queries together, reference the results of other queries in your queries, etc. So you can start to see how this becomes very powerful. Lots of stuff that you can do. Next week, as I mentioned, we will get a little bit deeper into this. So we'll do sort of a quick review of this, and then we'll get into a bunch more ways that you can use SQL to do some fun data analysis kind of stuff within Hex. Last thing I'll say is that if anyone is using SQL in any of your classes or internships or anything like that, SQL will largely look like this, be written like this in any tool that you're using. So you may not be using Hex specifically. There's a bunch of other clients or applications that you could be typing SQL into. It will all look like this. In some cases, you're going to need to put a semicolon at the end of an individual SQL statement. Hex does not need you to do that because it's got this little cell mechanism. But if you're writing SQL elsewhere, you may need to put a semicolon at the end. But otherwise, this will largely look the same wherever you're writing SQL, which is pretty cool. This is not a ton of keywords to remember, relatively short list. There's a lot you can do with it. All right. Cool. Okay, so that's all I've got for today. The Hex account that you have should work, I think, for at least the next 6 months or so. So you can go ahead and use that. You can create new projects in there, use that for any SQL that you want to be writing. As a quick heads up, if you want to be trying this with any other data that you have, you can actually upload any data that you have in a spreadsheet or a CSV file to the file section of Hex here. So if you have a big spreadsheet, you want to practice writing some SQL on the data that's in there, you can upload your spreadsheet right in here and start running queries on the data that's in there. All right. We'll talk about this a little bit more next week. When you do that, you'll need to do one step here, which will move it from the file into the data frame. It does it for you. It just does a little copy paste thing. But please feel free to use that. I think this is one of the easiest and most sort of user-friendly tools for writing SQL. And if you already have a spreadsheet somewhere, that's a great way to sort of play around and practice. Okay, that is everything for today. On this page that we started with at the beginning of class, the Digital Lounge has a little feedback form. If you have any feedback about this session, I would love to hear it. Helps the Digital Lounge know what's helpful to you all. I also threw my email on there if you want to reach out about anything. And then I'll hang around for 5 more minutes or so if anyone has any questions. Cool. Thanks everyone for coming.